Alright, let's go. Number 10, the WOW signal. On August 15, 1977, astronomer Jerry Ehman was reviewing printouts from the Big Ear radio telescope at Ohio State University. The observatory had spent years scanning the sky for narrowband signals, the kind of transmission theorists predicted an alien civilization might send. Most nights produced nothing but noise. But that August evening, Ehman found a sequence of characters so anomalous that he circled them in red ink and wrote a single word in the margin: WOW. The signal lasted 72 seconds, the exact duration the telescope would record a single point in space as the Earth rotated past it. Its frequency sat precisely at 1,420 MHz, the resonance of neutral hydrogen, the most abundant element in the universe, and the frequency scientists had specifically identified as the one an intelligent species would most likely choose for interstellar communication. The signal was 30 times stronger than background noise. It came from the direction of the constellation Sagittarius, from a region of space with no known stars, no known planets, no known anything that should have produced it. What makes the WOW signal particularly unsettling is what happened next. Nothing. Astronomers turned every available telescope toward that patch of sky. They listened for weeks, then months, then decades. The signal never repeated. No transmission of similar strength, frequency, or character has ever been detected from that location. For 48 years, we've been listening to silence where something spoke once. Every proposed natural explanation has collapsed under scrutiny. A 2017 theory suggested the signal came from hydrogen clouds surrounding two passing comets. The hypothesis was mathematically disproven within months. Clouds of that composition couldn't produce a narrowband signal at that intensity. Interference from Earth was ruled out by the signal's characteristics. Satellites were ruled out by the frequency, which is internationally protected from transmission. Every conventional source has been systematically eliminated. What remains is a 72-second transmission from an empty region of space at precisely the frequency we'd expect an intelligence to use. Detected once, never repeated, never explained. The mathematics of probability suggests that random noise cannot produce a signal of that specificity. Something generated it. Something chose that frequency. Something pointed it at Earth for 72 seconds in August of 1977 and then went silent. We have no framework to understand what happened that night, only the certainty that it did. Number 9, the missing antimatter. According to the standard model of particle physics, the Big Bang should have created equal amounts of matter and antimatter 13.8 billion years ago. When matter and antimatter meet, they annihilate each other completely, converting their mass into pure energy. If the early universe contained equal quantities of both, they should have destroyed each other within the first fractions of a second, leaving behind nothing but radiation expanding through empty space forever. But that's not what happened. We exist. Stars exist. Galaxies exist. The universe is made almost entirely of matter, with antimatter appearing only in trace amounts produced by cosmic rays and radioactive decay. For every billion antimatter particles that existed in the first moments of creation, 1,000,000,001 matter particles existed alongside them. That single extra particle per billion is the reason everything you've ever seen, touched, or loved has the right to exist. We cannot explain this asymmetry. Physicists have searched for decades to find the mechanism that tipped the balance. The Large Hadron Collider has smashed particles together trillions of times, looking for some fundamental difference between matter and antimatter that could account for the imbalance. The differences they found are real, but insufficient. They account for perhaps 1 part in 10 billion of the observed asymmetry. The rest remains completely unexplained. What makes this mystery particularly unsettling is what it implies about the laws of physics themselves. Something in the earliest moments of the universe violated a symmetry that should have been absolute. Either our understanding of fundamental physics is wrong in some profound way, or something intervened in the first trillionth of a second to ensure the universe would contain matter rather than emptiness. We don't know which possibility is true. We only know that without that unexplained tilt toward matter, nothing would exist to ask the question. You are here because something broke the rules, and we don't know what. Number 8, the Great Attractor. In 1973, astronomers noticed something strange about the motion of our galaxy. The Milky Way wasn't simply expanding outward with the rest of the universe. It was being pulled, along with hundreds of thousands of other galaxies, toward a specific point in space at approximately 600 kilometers per second. Something enormous was dragging a significant portion of the observable universe toward itself, and nobody knew what it was. The region became known as the Great Attractor. It sits about 250 million light-years away in the direction of the constellations Centaurus and Hydra. The gravitational mass required to produce the observed motion is staggering, equivalent to tens of thousands of galaxies worth of material concentrated in a single area. Whatever lies at that point is one of the largest structures in the known universe. The problem is we can't see it. The Great Attractor lies behind what astronomers call the zone of avoidance, a region of sky obscured by the dense dust, gas, and stars of our own galactic plane. Looking toward the Great Attractor from Earth is like trying to see a mountain through a fog. The Milky Way itself blocks our view, hiding whatever cosmic structure is pulling us across space at inconceivable speeds. What makes this mystery particularly disturbing is what we've discovered since. In 2016, astronomers found something even larger pulling the Great Attractor itself. This structure, called the Shapley concentration, lies another 500 million light-years beyond, and it's drawing the Great Attractor and everything it's pulling toward an even more massive gravitational center. We are not simply being pulled toward one unknown object. We are being pulled toward an unknown object that is itself being pulled toward something larger still. The implications extended to territory we cannot map. If the Shapley concentration is being drawn toward something else, the chain continues indefinitely into cosmic structures we have no ability to detect. The Milky Way, with its 400 billion stars and whatever civilizations may exist within it, is a passenger in a current flowing toward a destination hidden from every instrument humanity has ever built. We know we're moving. We don't know where. Number 7. Fast radio bursts. On July 24, 2001, a radio telescope in Australia detected a pulse of energy that lasted 5 milliseconds and released as much power as the sun produces in 3 entire days. The signal came from somewhere beyond our galaxy, from a source so distant that the pulse had been traveling for billions of years before reaching Earth. Nothing in the known universe should have been capable of producing it. The detection was dismissed as an instrument error and forgotten for 6 years. In 2007, astronomer Duncan Lorimer re-examined the archived data and realized the signal was real. Something in deep space had released an almost inconceivable amount of energy in a fraction of a second, and then gone quiet. Since then, radio telescopes have detected hundreds more of these events, now called fast radio bursts. Each one follows the same basic pattern: an intense pulse of radio energy lasting milliseconds, releasing the energy output of decades of solar activity originating from points across the sky with no apparent pattern. What makes fast radio bursts particularly unsettling is that we have no idea what produces them. Proposed explanations include magnetars, which are neutron stars with extreme magnetic fields, colliding black holes, evaporating primordial mini-holes. None of these hypotheses fully account for the observed characteristics. Some bursts appear once and never repeat. Others pulse from the same location repeatedly, following patterns that some researchers have described as mathematically suggestive. In 2020, astronomers detected a fast radio burst from within the Milky Way itself, the first ever found in our own galaxy. The source was a magnetar, which seemed to confirm the leading hypothesis. But the energy released was orders of magnitude weaker than the extragalactic bursts we'd been detecting for years. If magnetars produce fast radio bursts, they don't produce them at the scale we're observing from outside the galaxy. Something else is happening in deep space, releasing pulses of energy that dwarf anything our local universe can generate. And we have no coherent explanation for what it might be. Number 6. The cold spot. In 2004, astronomers analyzing data from the Wilkinson Microwave Anisotropy Probe discovered a region of the sky that shouldn't exist. The cosmic microwave background, the remnant radiation from the Big Bang, is remarkably uniform across the entire observable universe. Tiny variations exist from point to point, but they fall within narrow statistical ranges predicted by our models of early cosmic evolution. Except in one place. The region is called the CMB cold spot. It sits in the southern celestial hemisphere and spans roughly 1.8 billion light-years across. Its temperature is about 70 microkelvin colder than the surrounding background radiation, a deviation so extreme that the probability of it occurring through random cosmic evolution is less than 1 in 1,000. Something created a region of space fundamentally different from everything around it, and we don't know what. One hypothesis suggested the cold spot marks an enormous void, a region of space nearly empty of galaxies, which could theoretically produce the temperature deviation through gravitational effects on passing light. Follow-up surveys in 2015 and 2017 failed to find a void of sufficient size. Whatever caused the cold spot, it wasn't simply an absence of matter. What makes the cold spot particularly unsettling is the theory that has survived every attempt to disprove it. Some cosmologists have proposed that the cold spot is evidence of a collision between our universe and another universe in a multiverse. In this model, universes occasionally brush against each other during cosmic inflation, and the impact leaves imprints on the cosmic microwave background. The cold spot, according to this theory, is a bruise, a mark left on our reality by contact with another reality that exists parallel to our own. We cannot prove this hypothesis. We also cannot disprove it. What we can say with certainty is that there is a region of space 1.8 billion light-years wide that doesn't match the rest of the universe, that every conventional explanation has failed to account for it, and that the multiverse collision theory remains a viable scientific possibility. You live in a universe that may carry the scar of contact with something outside itself. Number 5. Boyajian's star. On October 14, 2015, astronomer Tabitha Boyajian published a paper describing the strangest star ever observed. Officially designated KIC 8462852 and located 1,470 light-years away in the constellation Cygnus, the star was dimming in ways no known stellar phenomenon could explain. Over a period of years, the Kepler Space Telescope recorded the star losing up to 22% of its brightness in sudden, irregular dips. A planet passing in front of a star typically reduces its light by 1% or less. Something blocking 22% of a star's light is blocking an area equivalent to hundreds of planets' worth of material. The dimming events followed no periodic pattern. They occurred at irregular intervals, had different durations, and produced different magnitudes of light loss. No natural model of stellar behavior accounted for what astronomers were observing. The star was also undergoing a gradual, long-term dimming, separate from the sudden dips, losing about 14% of its brightness over the course of a century, according to old photographic plates. Every natural explanation proposed has failed to fit all the data. Comet swarms were suggested, but the required number of comets exceeded any plausible scenario. Dust clouds were proposed, but the temperature signatures didn't match. Circumstellar debris was considered, but the geometry didn't work. Each hypothesis explained some of the observations, but contradicted others. What makes Boyajian's star particularly unsettling is the hypothesis that remains mathematically viable after every other explanation has failed: an artificial megastructure. A construction of such enormous scale, built around the star by some advanced civilization, that portions of it periodically block substantial fractions of the star's light as they move through their orbits. The theory is not preferred because it assumes the existence of beings we have no evidence for, but it has not been ruled out. Astronomer Jason Wright, who proposed the megastructure hypothesis, has stated clearly that such theories should be the last resort. After all, natural explanations fail. More than a decade after discovery, the natural explanations continue to fail. Boyajian's star continues to dim in patterns we cannot model. Something is orbiting it, and we do not know what. Number 4. The hum of the universe. In 2023, astronomers working with the Nanograv collaboration announced that they had detected something no human had ever sensed before: a low-frequency vibration permeating the entire fabric of space-time. A slow rhythmic wave measured not in seconds, but in years. The universe, they confirmed, is humming. The detection took 15 years of observations, monitoring the timing of pulsars scattered across the galaxy. Pulsars are dead stars that rotate with clock-like precision, emitting radio pulses that arrive at Earth with intervals accurate to billionths of a second. By watching how those intervals subtly varied over more than a decade, astronomers mapped gravitational waves passing through the space between us and the pulsars. The waves were there. The universe was moving. The source of this gravitational wave background is not fully understood. The leading hypothesis is that it comes from the combined signals of supermassive black hole binaries across the cosmos, pairs of black holes orbiting each other so slowly that a single orbit takes millions of years. As they spiral toward eventual collision, they stretch and compress space-time itself, sending waves rippling outward at the speed of light. The combined output of every such pair across the observable universe would produce exactly the kind of low-frequency hum Nanograv detected. But the hypothesis is not confirmed. The signal contains features that don't quite match the predicted pattern from black hole mergers. Some researchers have proposed alternative sources: cosmic strings, theoretical one-dimensional defects in space-time left over from the Big Bang, primordial gravitational waves from cosmic inflation itself, phase transitions in the early universe that released unimaginable energy into the fabric of reality. Any of these could contribute to the hum. We don't know which or in what proportion. What makes the universal hum particularly unsettling is what it represents. You are immersed in it right now. Gravitational waves with wavelengths measured in light years are passing through your body at this moment, stretching and compressing the space between your atoms by amounts too small to feel but measurably real. The universe has a background note. Something is producing it. We can hear the song, but we cannot identify the singer. Number 3, the axis of evil. When scientists mapped the cosmic microwave background in detail, they expected to find a uniform pattern of random fluctuations across the sky, reflecting the chaotic conditions of the early universe. The principle of cosmological isotropy, one of the foundational assumptions of modern physics, states that the universe should look roughly the same in every direction. There should be no special axis, no preferred orientation, no cosmic up or down. What they found instead was an alignment so unexpected that physicist João Magejo gave it an informal name that stuck in the scientific literature: the axis of evil. Analysis of the cosmic microwave background revealed that its largest-scale temperature variations are aligned with each other and with the plane of our own solar system. The universe appears to know which way our planet orbits. This should not be possible. The cosmic microwave background was emitted 380,000 years after the Big Bang, long before the Earth, the Sun, or the solar system existed. Its pattern is frozen from the earliest epoch of cosmic history. There is no physical mechanism by which primordial radiation from the infancy of the universe could align itself with the orbital plane of a planetary system that wouldn't form for another 9 billion years, and yet the alignment is there. Multiple independent analyses have confirmed it. The probability of it occurring by chance is less than 1 in 10,000. Several explanations have been proposed. Instrument error was investigated thoroughly and ruled out. Local contamination from our galaxy was considered and eliminated. Some researchers have suggested that the alignment reveals a fundamental flaw in our cosmological models, that the universe may not be isotropic after all, and that our assumption of uniformity is incorrect at the largest scales. Others have proposed that the observable universe has a preferred direction imprinted from the moment of its creation, for reasons we do not understand. The truly unsettling possibility is one most cosmologists resist openly acknowledging. If the axis of evil is real and is not an artifact of measurement or local effects, then something about our particular location in the universe is connected to the largest scale structure of reality itself. The ancient cosmic signal remembers us before we existed. We do not know how this is possible. We know only that the alignment is there, that it should not be there, and that every attempt to explain it has failed. Number 2. Dark matter. In 1933, astronomer Fritz Zwicky was studying the Coma Cluster, a group of roughly 1,000 galaxies bound together by gravity. He measured the motion of galaxies within the cluster and found something impossible. The galaxies were moving so fast that the cluster's visible matter couldn't possibly hold them together. At the speeds observed, the galaxies should have flown apart billions of years ago. Something was providing additional gravitational attraction, something we could not see. Zwicky called it Dunkel Materie, dark matter. His findings were largely ignored for decades. Then, in the 1970s, astronomer Vera Rubin measured the rotation of individual galaxies and found the same problem at smaller scales. Stars at the edges of galaxies were orbiting far faster than the visible mass should permit. Every galaxy she studied required vast amounts of invisible material to hold itself together. The discrepancy wasn't a measurement error or a local anomaly. It was universal. Current estimates indicate that dark matter makes up approximately 27% of the total mass energy of the universe. Ordinary matter, the stuff that forms stars, planets, and every living thing, accounts for less than 5%. The universe we can see is a small fraction of what exists. The rest is something we cannot detect directly, cannot capture in any instrument, and cannot identify with any known particle. For 90 years, physicists have searched for dark matter particles. The most sensitive detectors ever constructed have been buried in deep mines to shield them from cosmic rays, filled with exotic materials and monitored continuously for signs of dark matter interaction. Decades of searching have produced nothing. Every candidate particle proposed has been ruled out by increasingly precise experiments. The theoretical framework of dark matter works perfectly to explain cosmic observations. The particles themselves refuse to appear. What makes dark matter particularly unsettling is what it reveals about our ignorance. The universe is dominated by something we cannot see, cannot touch, and cannot detect through any known means. It passes through your body constantly. Trillions of dark matter particles are moving through the Earth and through you at this moment, affecting nothing and leaving no trace. Yet without this invisible substance, galaxies would not exist. Stars would not have formed. You would not be reading this. Reality is built on a foundation we cannot see, and after 9 decades of looking, we still have no idea what it is. Number 1. Dark energy. In 1998, 2 independent teams of astronomers led by Saul Perlmutter, Brian Schmidt, and Adam Rees were measuring the expansion rate of the universe. They expected to confirm what every cosmologist assumed was true, that the expansion, which began with the Big Bang, should be slowing down as gravity pulled matter back toward itself. The only question was how quickly deceleration was occurring. The answer would determine whether the universe would eventually collapse back into a singularity or expand slowly forever into cold, empty silence. The data made no sense. The expansion was not slowing down. It was speeding up. Something was pushing the universe apart with increasing force, overcoming the gravitational attraction of all the matter in all the galaxies that have ever existed. The force was invisible, undetectable by any direct means, and yet it dominated the behavior of reality at the largest scales. The teams checked their data for years. The results held. The universe was accelerating and something was causing it. The cause was given a name: dark energy. The name was an admission of ignorance. We called it dark because we could not see it. We called it energy because whatever it was, it behaved like a repulsive force permeating every cubic centimeter of empty space. Current measurements indicate that dark energy makes up approximately 68% of the total mass energy content of the universe. It is the dominant component of reality, and we do not know what it is. Every attempt to calculate dark energy from first principles has failed catastrophically. Quantum field theory predicts that empty space should contain a certain amount of inherent energy. When physicists calculated what that energy should be, they arrived at a value 120 orders of magnitude larger than what we actually observe. This is the worst prediction in the history of physics. The discrepancy is so enormous that it suggests something is fundamentally wrong with either our understanding of quantum mechanics, our understanding of gravity, or our understanding of both. The truly horrifying implication isn't that we don't know what dark energy is, it's what dark energy is doing. The acceleration is not constant. Some observational evidence suggests the force may be strengthening over cosmic time. If that trend continues, dark energy will eventually overcome every other force in the universe. It will tear apart galaxy clusters, then individual galaxies, then solar systems, then planets, then atoms, then the subatomic particles themselves. The fabric of spacetime will be stretched faster than the speed of light, and nothing will be able to hold together against it. This end state is called the Big Rip, and some models predict it could occur in as little as 22 billion years. The universe is 13.8 billion years old. We are living in the middle of a story whose author we cannot identify, whose mechanism we cannot explain, and whose ending has already been written into the equations of the reality that contains us. The dominant force in the cosmos is something we do not understand, and it is slowly pulling everything apart. If you want to see more videos like this, click the video on screen now and make sure to subscribe.